Hello, ladies and gentlemen. I hope you're all doing well. Root Beer here with question number 16 on the 2008 Fermat paper. That's the grade 11 multiple choice contest. And what have we got here? In the diagram, the 6 small squares all have the same side. Very nice, very helpful. And that's going to be 2. Okay, if we need that. So I might be calculating some lengths or areas. Lines are drawn from O to P and O to Q. The measure of POQ in degrees, accurate to 1 decimal point. We don't actually need the 2. We just need to know that these are all squares. But I mean, the 2 could be helpful if you really wanted it. So accurate to 1 decimal place, so immediately I'm reaching for my calculator. Unless I get very lucky, I'm going to probably have some weird trig thing that I'm going to have to just compute with my calculator, and there'll be no other way around it. But let's see where this goes. Okay, so we've got, we'll just quickly reproduce our picture here. I'll even show you that the 2 doesn't matter here. So we've got O down here, we've got O to P, and O to Q. I'm just going to call the side length S. If you need a 2, go ahead. But let's highlight some triangles. So we've got the purple triangle. And it's a nice little right angle triangle here. And we've got the angle, say, P, O. Q's already in use, so we'll call this R. And so we'll get another triangle here, the light blue triangle. It's also right angled, because all these squares. QO to, let's call it capital S. Now the angle that we want, POQ, is just the angle POR minus the angle QOS. Okay? No harm there. Just this black angle is the one we want. That's the purple angle minus the blue angle. So how are we going to figure out these 2 angles here? Well, we have some trigonometry at our disposal. If I want this angle theta here, and I, for example, know the ratio of the opposite and adjacent sides, then I'll write this below here. Let's not let it get in the way of our calculations. Tan of theta is going to be opposite over adjacent. And so what we need is not the actual sides themselves, but the ratio of the sides. And if we want the angle theta itself, we just use arctan or tan inverse, depending on what button your calculator shows. So POR, well, that's 2s over 2s. QOS, that's 1s over 3 s's. But now the s's don't matter. The fact that it's 2 doesn't matter. We get tan inverse of 1, which is 45. That one's not bad. But it's this next one. I don't know what gives me a tan of 1/3. 1/3. And so that's where the trusty calculator comes in. And do make sure you're set to degrees. They are asking for degrees, right? Not radians. Yeah, they're asking for degrees. So do make, most calculators are by default set to degrees, but you just want to make sure. So we'll get tan inverse, and that's about 18.43. So we just take the difference of those 2. And we get 26.565 degrees. I would probably round that up to 26.6 degrees, but let's see what they do. 26.6, there it is. So that's C, and there isn't any ambiguity there. So there we go, answer C, and that does question number 16 quite nicely. Up next, of course, will be question number 17. If you want to be kept up to date or just show your support, feel free to like or subscribe. But I will see you for question 17 in the next video. Thanks for watching.